I'm Gary Hansen, and I've got the best job at UCSB. We have built this entrepreneurship program over the last almost a decade now, and most deliberately in building a curriculum. I'd like to review just a little bit about the scope of the program so that you understand the context in which this competition is taking place. And then I'm going to introduce one of our primary sponsors, main sponsors for this event, an alum, and also a serial entrepreneur. And then we'll begin the competition with the students themselves. This is the 8th, did we, somebody changed the slides back, so I'm going to have to, there we go. It's a technology management program. We call it Value Adding with Passion. Our mission is educating men and women to create economic value through new technologies. Our vision, academic programs of excellence designed to meet the entrepreneurial and leadership needs of technology-driven businesses, and our values, passion to commercialize research and invention. Now, you're going to hear a lot of students come up and talk about mission, vision, goals, building their companies. My guess is you probably thought that was pretty boring, so let me tell you what we really are. We really have really great classes with fantastic faculty and very, very bright, motivated students from across the UCSB campus studying how to bring new technology products to market. Our program is all elective classes, so nobody has to take a single one of our classes to graduate from UCSB. We're the fastest growing program on campus. Most students take multiple classes. They do it as an overload. They do it with a passion. They seek us out. They stand in line. And in many of our classes, we are not able to take anything other than seniors because we simply don't have the capacity to take juniors and sophomores. We have more extracurricular business education experiences than many leading business schools. So in addition to activities within the classroom, we have a number of engagements so that students learn by doing. And it's all integrated together to prepare our students to assume careers of significance in tomorrow's technology-driven companies. The College of Engineering, so we're not a business school, we're located within the College of Engineering, and it's a leading college of engineering, one of the finest in the United States and probably within the world, with technical excellence, departments like materials science, one of the top 4 programs in the world, chemical and electrical engineering among the top 15, world-class institutes, Nobel laureates, and leaders in particular types of technologies, material science, solid-state lighting, high-speed electronics. So what's a College of Engineering doing with a focused business education? Well, one of the things that we have is a conference that we put on where the question is, if you're a technologist and you're doing some of the cutting-edge technical research in critical issues of the day, how do you bring that technology to the market? We do that with our Technology Summit. We've joined with our Bren School to create an eco-entrepreneurship program so that students in the Bren School learning environmental studies can study with our engineering and science students and build new solutions for today's problems. So what we do with the technology management program is transition from technical research to bringing technology to the marketplace, going from pure science to products that have been successfully introduced and to change the world. We have an integrated approach to education. Unlike other programs that may say, oh, it'd be great to have some engineers in here, let's just have them take some classes that already exist. Every one of our classes is designed specifically for this program, and it's designed for students from across the campus. So roughly 1/2 to 2/3 of the students in every classroom is from science and engineering, and the other roughly half or less are from students from across the campus. So immediately students are totally submerged within a diverse environment. So the faculty try and provide some theory-driven learning. We bring in practitioners, industry experts to talk about how it's actually done, and the students learn to integrate and operate in sort of both worlds simultaneously. We think about their careers and launching, how they progress. Where do they get insight into the world that they will soon be party? We have a lecture series. We have what we call EAT, Entrepreneur at the Table, where they meet with anywhere between 15 to 20 entrepreneurs and successful business leaders, and leaders in innovation, where we bring leaders from across the world to come and talk about cutting-edge issues so that students can gain an insight into the world that they're going to be joining. And then we give them an opportunity to practice their problem-solving techniques. Internships, industry conferences, and the business plan competition, which you see today. And then we have placement services, venture networks, venture creation. What's the social network? If you want to get something done, a lot of times it's knowing the right people. A student in the technology management program should be able to graduate not only with an education, a set of practical experiences, but also a Rolodex of some of the leading entrepreneurs and business people in the world. We give a certificate to our undergraduates, and we also have a graduate certificate. This is a picture of a class a couple of years ago. Our growth has been fairly significant, and I don't think there's too many programs with frozen state budgets that have been able to grow quite like that. Great management faculty. This is just some of the faculty in one of the labs talking to a graduate student, talking about how their technology may make a difference. We offer a radio show, a weekly radio show, where we have students interviewing leaders from across the country. The nice thing about a radio show and doing interviews is you can bring people from any place in the world together simultaneously to talk about an issue. They don't have to be there. Student Entrepreneurs Association, the building the entrepreneurial talent through the new venture competition, and you'll see that today. Remember, none of these students have come through a business school. We started this program in January, and today you'll see the results of their activities and interests. And then we actually give them money. It seems to be a big motivator, but in addition, it sort of gets them started. So this is a picture here of Ethan Smith, who I think is in the audience today. Was motivated to go on and has pursued his business idea. He was at graduate school in London and won 2 or 3 competitions there and is now continuing to seek to create his company. So in addition to creating bright students, we also create companies. Inogen, the founders Brian, Allie, and Brenton are here today. And actually, could you guys stand just to be recognized? They won the competition 3 years ago? 6? No way. All right. So not only were they too young to be entrepreneurs, I think they're probably the only manufacturing company that started in Santa Barbara County in the last 2 or 3 decades. This is a group of students who have learned that if you say it can't be done, they'll find a better way to do it. Sirigen, a link between an undergraduate and a graduate student. We created a company, 2 students created a company, and then a company called Inlustra that came out of one of our famous laboratories. I'd like to thank the number of individual supporters that make the program possible. All the things that you see here today are made possible by friends, supporters that have made this program grow and do quite well. Students, mentors, advisors, supporters, people who attend our events, that's what makes the program great. Students come literally every day into my office and ask how they can join, how can they be a part of this activity.
Good afternoon, everyone. My name is Sam Galley, and I'm presenting MedAlive, a company that sells health monitoring software to hospitals. Now, our technology story begins with a personal experience of one founder in 2003 when his grandmother, Florence A. Rothman, was admitted to a hospital for routine heart valve surgery. During the first 3 days of her recovery, she improved rapidly, gaining strength and vitality. From that point on, however, due to undiscovered complications, she began to decline, eventually leading to extreme illness and near death. Now, she was caught, but only at the last minute, and eventually she was discharged a week later. Unfortunately, the underlying cause of her decline was never addressed, and she died in the ER 4 days later. Now, with healthcare technology where it is today, how could this happen in the United States, where we supposedly have the best and most expensive healthcare system on the planet? To understand that question, we have to look at what a doctor faces on medical surgical wards like the one where Florence was treated. Simply put, doctors have too much data. By data, we mean a single measure of one single health parameter, for instance, your heart rate, your blood pressure. Given one single data point, a doctor can say that that is too high or too low, but that alone does not illustrate a full picture of a patient's health. Given multiple data points for various health parameters, a doctor can get a sense of a patient's health and design a course of treatment accordingly. This process, however, must be performed by doctors very quickly and just from looking at a page full of numbers. Since doctors can have 15 to 40 patients, the data in a medical record can quickly become overwhelming, especially when a doctor is expected to give personalized care for every single one of his patients. What the healthcare system needs is an effective, reliable, and easy-to-use tool that will help healthcare professionals quickly evaluate a patient's medical process by converting the current, arduous, numerical data into visual trends over time. Our solution to this problem is the MetaChart. Our MetaChart was able to extract vital signs, nursing assessments, and other forms of health tests from the existing existing electronic medical record and analyze them with our patent-protected algorithm to create a chart of a patient's health with no extra input as the data is already contained within EMR. Now, what if Florence's doctors had a MetaChart? They would have seen each score for her health during the entire course of her recovery. This in and of itself would have been useful, but our technology actually goes one step further. Our MetaChart can also show the trend of a patient's health over time. What the healthcare professionals missed was the progression when Florence initially got better, but then began a downward trend. They were not aware that she was in the middle of a serious deterioration until she reached a critical condition. After designing the algorithm, Sarasota Memorial Hospital, the hospital where Florence was treated, allowed our development team to use 60,000 more patient records to validate the index, and they took it upon themselves to see if Florence's story was a personal one or one in which it was hospital-wide. Here's what they saw. And keep in mind, this is data from a real patient at Sarasota Memorial Hospital. The actual intervention was where a doctor was called to treat a patient who had a significant drop in health. With MedAlive, healthcare professionals would be able to catch the trend where you see it indicated on the chart above. Now, if you can tell the difference between where the actual intervention happened and where it should have happened, then you're a certified MedAlive MD. The point here being is that with MedAlive, there would be no question as to when to call the doctor. After seeing this need for our technology, we presented it to doctors and nurses at Sarasota Memorial Hospital, an electronic medical record user network, and a national conference on healthcare information technology to ask them if they saw the need as we saw it. Across the board, the answer was a resounding yes. We also found that the Institute of Medicine, in their 1999 To Err is Human publication, they reported figures that 98,000 Americans die annually due to medical errors just like this one. In the same report, the total cost of preventable errors is some $8.5 billion to the U.S. market alone. At this conference, we also found health IT vendors and electronic medical record companies who were interested in partnering with our company after a market validation period. Further, we found that our MetaChart could potentially have more uses than even we intended. What you see here is our MetaChart dashboard, which is an interface that a doctor would use to visualize the health of all their patients. Not only can you see one patient, for instance Florence, but also all of the patients at once. By going to the market and presenting our product concept, in addition to signaling potential crises, we also found two other useful applications. First, the product could assist when prioritizing care by visually highlighting, as we have done here, the patients that are not doing as well so that a doctor would begin his shift by seeing these patients first that need him the most. Those are the ones in red. Secondly, the product could help assign nursing staff according to the intensity of patient care required. It could also prevent one nurse from getting all of the most complicated cases, and it would help spread out the care. Additionally, our module is easy to install and use with the hospital's existing electronic medical record system, which come from some of the electronic medical record vendors shown here. Now, over the past 2 years, we've been able to form a great team. On the business side, we have Nancy Pinot, Felix Recht, myself, and Daniel Rothman. Between us, we have multiple years' experience in healthcare, finance, and software design. On our product development side, we have approximately 75 years of software and data analysis experience building computer technology like the one that you have heard about here. We've also been able to get several key medical and business advisors. From this extensive list, I'd like to highlight on the top left Duncan Finley, who is our physician champion at Sarasota Memorial Hospital. And on the top right, John Romano, an entrepreneur who is founder and CEO of Medcon, a medical company which sold to McKesson for $105 million in 2005. Getting to our market space validation, we found that there's a $1.2 billion market for technology like ours. That spending is spread out over some 2,260 hospitals across the United States and is expected to grow 20% for the next 5 years. Lastly, to capture 70% of the available market, we will only have to adapt our module to fit within 5 electronic medical record systems from the list you saw before. In terms of competition, there are 2 different class distinctions. Potential competitors include VisICU and Apache, which are intensive care unit-specific products. The difference here is that the ICU is a ward where a number of different health measurements are monitored constantly through ICU-specific technology. On a med-surg ward, which is the niche that we are targeting, the monitoring is less intensive as patients are assumed to be doing better. Biosignals, however, is a direct competitor. This UK-based company has recently moved its headquarters to Carmel, Indiana, got an FDA marketing clearance for marketing in the US, and secured venture funding in the amount of $8 million. The key differences between our product and theirs is that we correlate more health measurements, 22 more in fact. They also require parents to wear an additional medical device at all times. Basically, they're creating an ICU ward on the medical surgical ward, which only puts more strain on healthcare professionals who have to deal with an additional medical device. The current status of our technology development is that we have an alpha test ongoing at Sarasota Memorial Hospital, which we expect to complete in August of this year. Additionally, we are aggressively pursuing beta test sites where we can adapt our software into different electronic medical record systems, which we expect to complete in June of 2008. Finally, we are looking to publish our data in a medical journal sometime next year. For our business model, we decided on a per-patient charge, which is the current standard in the market. It is used by a number of different electronic medical record vendors, including VisICU and Apache. And initially, we will directly license our software to hospitals, and once we achieve some market traction, we plan on licensing our technology through electronic medical record software providers so that we can effectively use their distribution channels to get into hospitals more rapidly. Going off of that business model, we plan on charging $7 per patient when licensing to hospitals, which is fairly typical in our market space, and licensing to EMR vendors for $3.50 per patient. In our financials, we will start generating revenue in 2008, and with a combined direct hospital licensing and indirect licensing to EMR vendors. By 2012, we predict our product being used in 381 hospitals across the country, and we anticipate our income will be $21.5 million. Thus far, we have received $250,000 in funding from the Greenfield and Sarasota Memorial Healthcare Foundation, and of that, we have only spent $150,000 over the last 2 years of product development. Additionally, we have formed our medical and business advisory boards and installed at our alpha test site and found a number of hospitals that have shown interest in becoming beta test sites. Currently, we are seeking $1 million to get us to our next milestones, which consist of the following. We will install at 8 beta test sites, adapt our product into the different electronic medical record systems, and strengthen our management team. In our conversations with 2 EMR vendors, they told us that when we reach these milestones, we will be attractive partners for full integration within their electronic medical record system. With MedAlive technology, doctors and nurses will be better informed to make better diagnoses. By helping healthcare professionals focus more on what matters, your investment can help save lives. Thank you.
I have a couple of questions. Sorry. Oh, it's you. So the couple of questions are, I'm not familiar with the model where you charge per patient. I am familiar with like VisICU, and I believe they charge per bed, an annual cost per bed, as opposed to per patient discharge, which I just wonder if a hospital is willing to do that. Do you have any feedback which would support that? That's one question. And the second one is to integrate with an EMR. Do you need their cooperation, or can you do it without them?
Well, I think Felix can answer the first question the best.
So, what? Hello?
Can we get that one on?
Hello? It works. So actually we have talked to other software medical vendors, and it is an existing model in the market. So you're right, there are models based on beds, based on doctors, but there's also the model of per discharge. And we just think that it's very attractive to the hospital to just buy the product on the discharge number, because costs only occur if actually the patient is in the bed or is treated in general.
As for integration into different EMR platforms, we've actually done it thus far through an open development kit that the EMR platform has. And most of the platforms do have such an open development kit. They want to allow doctors to pick and choose different modules that they want to snap into their software.
Whose have you done it with?
At this point, we're not disclosing that.
Oh, okay.
I have a question about the novelty of your intellectual property. You are patenting a very particular approach to doing math, doing a calculation, algorithm. What keeps one of the many and up-and-coming and eager, aggressive EMR providers from just coming up with one of what's got to be sort of an infinite number of ways to combine the information together to provide some sort of aggregated output?
The scope of our patent is not limited just to the math. It's actually to part of the process of taking these health metrics and integrating them into a single score. It's not quite as broad as we would like. If we had been in the market 30 years ago, we could have grabbed it all, but we do have some good area covered, and we're working with a top law firm to make sure that we have all of our possible areas covered.
Have you talked to any of the medical insurance providers to see if there is a play through that channel?
That's something that is sort of first on our list when we're mostly done with beta testing. We want to say, okay, look, we saved these hospitals this much money, these many lives. What kind of incentives are you going to offer them to help us get into hospitals? And we think that that is quite possible, that they would support us in that.
Can you guide me through a little bit more in terms of the value proposition? You said you saved that much in terms of money, that many lives. So what's the actual ROI argument? What's the value proposition that you kind of put in front of the hospitals?
Well, we have actually seen that rapid response teams, those are teams that are called before a critical situation actually occurs, that they could reduce, for example, heart arrests by 30%. And as we have shown, we can see that we actually even give the nurses or the doctors a tool which allows them to call even earlier. So we expect that cost, like unwanted transfers to ICU units, is going to be reduced. I cannot put it in numbers right now.
To further expand on that, so the rapid response team, the idea behind it is that a nurse can, based on one parameter or her subjective judgment, call a rapid response team in order to better treat a patient. Now, these already exist within a number of hospitals, and so they're already starting to do research, and that was the figure that Felix had quoted, the 30% reduction in cardiac arrest.
If I could add something, if you can catch a patient's downtrend before it becomes serious, address it, and have them continue to recover, the patient gets out of the hospital faster and has a better chance of survival. Hospitals tend to have a sort of per condition fee. So if you treat a patient and it takes you a long time to get them healthy and out of the hospital, you're losing money every day beyond the expected length of stay that the insurance company will reimburse you for. We also expect that by saving patients' lives and limiting the amount of damage that could be caused by a medical error, we can reduce liability to the hospital.
Hi there. My name's Arnold Foreman. I'm up here with my colleague Brandon McKenna, and we're going to talk to you about magnetic MicroTag. Our goal is to develop and commercialize biocompatible microspheres for targeted medical applications. These applications include targeted drug delivery, biological separations, and targeted MRI contrast agents. The microsphere itself, depicted here, is composed of biocompatible polymer, shown in blue, and magnetic iron oxide nanoparticles, shown here in yellow. The biocompatible polymer is functionalized with antibodies per the application, and that's exactly what the microsphere is. There's a patent pending through the UCSB here on the fabrication of this material, and the prior funding comes from National Science Foundation, National Institutes of Health, and NASA. The microspheres can be used for targeted drug delivery, for targeted drug delivery. Typical drug delivery of chemotherapy agents, which would be to treat cancer, is done systemically. What this means is that if you have a localized cancer in the body, you must administer the drug to the entire body in order to get the drug to that cancer. The side effects of administering the drug to the entire body for cancer typically include hair loss, a compromised immune system, and nausea, just as some of the nicer things that happen to people. I think we're all probably pretty familiar with this. Cancer is prevalent enough in the United States that we've probably all seen this happen. The market here is quite big. In the US alone in 2005, $40 billion, 1.4 million new cases. 1 in 7 was female breast cancer. The most likely application of the microsphere for targeted drug delivery is in breast cancer applications. Let me explain how the microsphere works. So first, microspheres loaded with the drug of interest are injected into the body. And here's what makes the microspheres different than other targeted drug delivery applications or other targeted drug delivery vessels that have been proposed in the past. When the drugs go in, you can use a local external magnetic field on the body to increase the residence time or increase the likelihood that these microspheres will bind to the cancer cells, and they bind via the antibodies which are placed on the surface chemically. You can then remove the external magnetic field and apply a pulsed magnetic field, and this will release the drug in the vicinity of the cancer, and the side effects will be minimized to the surrounding healthy cells. There's much more drug delivered to the site than standard chemotherapy. The external magnetic field we like to refer to as magnetic steering. This externally triggered release with this pulse magnet also induces what's called hyperthermia. So this is a local heating of the area from the iron oxide nanoparticles, which are magnetic. This local heating also increases the efficiency of the therapy, the chemotherapy, which is actually delivered to the cell. The microspheres are made of materials that are known to be biocompatible. And what this means is that it'll bring us through FDA approval much faster. It's also classified as a medical device, not a new medical drug. I think we're all familiar with FDA trials taking up to decades sometimes for new medical drugs. This is not a medical drug. We're going to be targeting breast cancer with known antibodies, which are FDA approved, and known chemotherapy drugs, which are also FDA approved. The other important factor here is that not only can we target the cancer, but we can also image the cancer with MRI. So this is also something unique to the microspheres, not proposed in other materials. So this is also another market. So MRI imaging. So the MRI iron oxide contrast media market, which is just a quarter of the entire contrast media market, is $400 million a year. Standard MRI contrast agents are what we see over here on the left. So this is an iron oxide contrast agent that was introduced to blood vessels to help image a uterus. And so similar darkening of the pictures is what we expect, but localized only at the place where there's cancer in the human body when we use the microspheres. That gives us selective targeting contrast enhancement. So when you combine targeting, drug delivery, and imaging, you wind up with more successful treatment. The third application here is biological separations. The biotech industry spends $300 million a year on magnetic particle separations. This is about a fifth of what they spend on separations total. Purifications and separations are one of the most costly steps that the biotech industry must go through. They're often very difficult and inefficient. It's difficult to do this very selectively. The microspheres, because of their fundamental patent-pending fabrication method, are porous on the inside. This allows them to have approximately 50 times more absorbency than the leading competition. They're also, due to their chemistry, they're a very facile platform that can easily be tailored to target the specific separation of interest based on the type of antibody that you want to put on the surface. This makes us far more cost competitive with approximately a 30% reduction in cost over the leading competitor. Now Brandon will tell you some more about MMT.
Thanks, Arnold. So how are we going to take this potentially breakthrough opportunity and turn it into a business? Well, we foresee that it will be crucial to involve two alliances. And the first of these is a company that manufactures instrumentation, machines for expediting the process of bioseparation. And we foresee that we will supply the microspheres as in the form of a kit to sell alongside such instrumentation, and we'll receive revenue upfront and some milestone payments and, of course, royalties. Secondly, crucially, to both bioseparation and targeted drug delivery, but especially targeted drug delivery, will be an alliance with an antibody manufacturer. And we see this as a real win-win situation. An antibody manufacturer has to profit a lot from this because we would be giving them a new device that no other antibody company has, so they have a competitive advantage. This will allow them to reach broader markets with actual clinical application and provide them with a new income source that's potentially extremely substantial. MMT has a lot to profit from this too because we'll be asking for upfront payments just to help get us on our feet, plus milestone payments as FDA trials progress, and of course royalties. We'll be looking for an alliance which is able to absorb some or all of the costs of FDA trials as those continue, and will also profit from biochemical expertise and their available distribution channels. So how does this look financially? Well, we've done most of our financial analysis with regard only to bioseparation. The reason for that is because that targeted drug delivery is dependent on the FDA trials and the success with that. So as mentioned, we'll receive some royalties from the sales by the alliances. And we imagine that future sales will go through their distributors, so direct sales. We anticipate a gross margin of 40–55%, and that's based on a 30% cost reduction over currently available materials for bioseparation. And we anticipate that in year 5, we will have 15,000 units per year production. Now that's not a lot if you're making your favorite brand of cola, but if we're selling ours at $500 to $1,000 a pop, so that becomes substantial. So for funding, we estimate that we'll need $1.7 million, and that includes startup costs to move off campus, although we hope to be still closely allied with the UCSB. And that's enough that we can pursue government grants like SBIR or ATP grants and cover that. Now, what I want to point out just on this graph here is that again, emphasize that we, have a market for bioseparation, but you can see a dramatic spike there, obviously for a targeted drug delivery market. Now, that does assume that we've successfully completed FDA trials, but it's otherwise a somewhat conservative estimate because it assumes a fraction of a % of the total cancer market, and it also assumes a slow ramp rate, but whatever the market is that we can address, we estimate that we can capture 40 to 75% income of that market. And so with that, I want to talk about the members of MMT, a very stellar, dedicated cast. The advisory board, Professor McFarland is not just a professor, he's also a serial entrepreneur as well as a surgeon. Professor Herb Waite has expertise in biology and biochemistry, and he has been an integral part in the development of this new breakthrough technology. Dr. Bruce Altrock has industrial experience, and he also has specific experience researching antibodies. And of course, we have a devoted, extremely talented management team of researchers and businessmen. So in summary, we have a new patent-pending technology that's basically ready to go, or at least ready for targeted drug delivery to enter in vivo trials. It has a low cost of production, is made of readily available and biocompatible materials. And we've somewhat mitigated the risk of trying to say we're just entering a targeted drug delivery market because we have more certain application in bioseparation. Although for the reasons Arnold mentioned, we truly believe that we have great potential for targeted drug delivery. And of course, this is a business competition, but it's important not to forget the social impact of this, of course. And our product addresses, of course, a very important health problem that I'm sure we've all dealt with. And finally, we will succeed because we have just a stellar cast. And with that, I want to thank you for listening, and I also want to give a warm thanks to the whole TMP program. Catherine, Gary, all the mentors, and I'm sure we just don't know how much work has gone into it, actually, and we really appreciate this tremendous opportunity. So thank you very much. That's all.
Do you have any idea what the FDA process would be? In other words, like what size trial and what kind of endpoints they'd be looking for and stuff like that?
Sure. We believe that because all of the components that make our microspheres are made out of biocompatible, already approved materials, that this qualifies for what's called a 510K, which is basically a faster throughput through FDA trials. So the estimates for that are 90 to 100 days, including inspection of the manufacturing facilities.
So you don't think any clinical trial is going to be needed in addition to the 510K?
No, we first planned clinical trials in animals, so in vivo in animals, and following successful trials there, then we plan to move towards getting FDA approval.
I'm sorry, I didn't hear that last. Say it again, please.
After we've proved that it does work in animals, then we plan to move towards FDA approval.
With human clinical trials?
Yes, yes.
Yes.
So do you have any idea what size of trials those would need to be?
It depends on what the FDA is asking us to prove. If they want us to prove that, so let's say we take an FDA-approved antibody or an FDA-approved drug, and they want us to prove that when we tether that antibody to our surface, that we don't change the functionality of that antibody, then it could be more extreme. But since we're planning on taking things that are, or it could be more lengthy, but since we're planning on taking things that are already FDA-approved, we assume that the FDA trials should be more streamlined.
And the cost for a 510K is pretty minor also, I mentioned that as well.
There's several other companies that are also pursuing kind of microspheres and research around those. Aren't they already further ahead in terms of what you guys are doing?
As far as we know, everything that's been investigated so far, I mean, if you read, for instance, scientific literature, there's a lot of talk about the multifunctional nanomedicine device. And everything that talks about it is completely hypothetical. We're saying that we've achieved all of the hypothetical aspects of this device and combined it into one drug delivery system. So the other devices that are being developed or are available usually miss one of several key important attributes. So one of those is, well, okay, maybe you're using a liposome or something, but once you put it in the body, where does it go? How do you know it got where it's supposed to go? Ours allow direct imaging so you know right where it went. Others also rely on, for instance, local physical parameters, like more acidic conditions before they release their drugs. And ours have an advantage over that because we have triggered release. We externally tell them when to let the drug go. So we're aware of many of course, plenty of failed past attempts and current attempts at targeted drug delivery, but we believe that we have covered every aspect that is necessary to make this a reality.
What's your strategy towards staffing or managing the corporation?
Well, we know right off that we need to get a biologist, a biochemist, for one, a technician. We ourselves have been conducting the research and plan to continue to do so. And then, the procedure is, I mentioned the low cost of production. It's a simple, there are only about 3 key steps in the process of this, which is really good for manufacturing. So, we don't need a league of technicians to work on this.
And there's minimal capital investment to do the process.
And we'll also collaborate with other clinical facilities such as Johns Hopkins or UCSF or something like that to do the biological tests.
Good afternoon. My name is Davis Breimer, and to your right is Alex Proctor, and we are here representing Active Life Technologies, prolonging active lifestyles through advancements in bone health technologies. For the next 10 minutes, I will be introducing you to the company, and Alex and I will both be available afterwards for questions. Bone health is a national problem. Bone health is actually, the musculoskeletal conditions cost the United States over $254 billion per year. This problem is not only significant, but it's growing. I would actually like to ask you, the audience and the judges, to think to yourself how old you will be in 13 years in the year 2020. Now, with that in mind, please consider the fact that in the year 2020, 1 in 2 Americans over the age of 50 will have weak bones. To many people, this is becoming less a statistic and more of a reality. And it's fairly evident why the years 2002 to 2011 are nationally and internationally recognized as the National Bone and Joint Decade. Our society as a whole has accepted the fact that an increase in age will evidently lead to a decrease in life. But Active Life Technologies did not view it the same way. For where there's a growing problem, we see a growing opportunity. One of our 4 mission statements of the Bone and Joint Decade calls for cost-effective prevention and treatment of musculoskeletal injuries and disorders. And this is exactly what we plan to do. The osteoprobe is the solution. Invented here at UCSB by physicist Dr. Paul Hansma, a principal inventor of the atomic force microscope, the osteoprobe is a small, handheld medical device that is very easy to use and measures bone strength properties such as elastic modulus, stiffness, hardness, and more. By using the handheld device and easily attachable, pre-sterilized, disposable tips, the osteoprobe can reach the bone to make essential measurements that cannot be obtained by any other existing technologies. The osteoprobe is a pioneering device that meets a currently unmet need. When considering the strength of bone, it's important to look at 3 different parameters: the bone architecture, how the bone is built, the bone mineral density, which is what the bone is made of, and the bone material and mechanical properties, how strong the bone is. While there are existing technologies that can measure the architecture and mineral density of bone through imaging techniques, there's currently no technology that can measure the material and mechanical properties of the living bone. When introducing a new technology to a market, it's important to ask the experts what they think about the existing technologies and how they feel the osteoprobe might fit into those. An experienced medical device consultant stated that imaging is limited because it is and will always be merely a correlation to bone strength. The head of a bone pharmacology group stated, "Imaging is the standard technology used because it is currently all that is available. The fact that the osteoprobe is the only technology with direct measurements of living bone strength has, from the feedback that we've received, generated a lot of excitement within the medical industry." So who are all these excited medical professionals? Well, because there's no such thing as a bone doctor, nearly any physician could end up seeing a patient with some sort of bone problem. Looking further into the applications, we distinguished 3 markets within the medical industry, including the research market, which is our preliminary market, specialized medicine, which is our primary market, and primary care physicians, which is our home run market. Within the medical market as a whole, these opportunities have a very logical flow from one to the next, as the research market is necessary to validate a product, and the specialized market is needed to gain credibility before reaching your home run market. While we did take the time to uncover the potential within each of these evolutionary markets, we also understand that it's very important to find a niche market to focus on first. As with any high technology product, the niche market is essential for technology adoption. After medical validation in the research market, the osteoprobe will initially be sold specifically to orthopedic surgeons, rheumatologists, and endocrinologists, and they will use this tool as a measurement, treatment, and rehabilitation device to easily and accurately assess the recovery of bone fractures, such as those caused by osteoporosis. So what does this mean? It means there will be a better information for the doctors to make a more accurate repair assessment at a lower cost and in less time. By narrowing down our potential market of 68,000 orthopedic surgeons, rheumatologists, and endocrinologists to the absolute target, we realize 3,400 unique osteoprobe customers within this niche market alone. When developing the business model, we took a look at the currently used technologies and found that they are very large and very expensive, ranging from $50,000 to $2.5 million. Due to relatively low manufacturing costs, we could sell the osteoprobe for a comparably low price of $50,000. On top of this, we will have an ongoing, constantly increasing revenue stream from the disposable tips. It is not very often that you find a medical device that could require less reimbursement from Medicare, consumables that could create a profitable device for the physicians, increased quality of care for the patient, and still drive a profitable company. This opportunity is what I like to call a win-win, win-win solution. The osteoprobe has several competitive advantages, namely the direct measurements of bone strength and the fact that our consumables will be an ongoing source of revenue. The device and method patents for the osteoprobe were filed in early 2006, and an additional patent was filed earlier this month, April of 2007. By talking to target customers, I was told that most new medical devices are heard of through thought leaders, publications, and trade shows. This remained consistent for both our preliminary and primary markets. The distribution channel was different in the fact that the research market does not require a distributor, while it is pretty much essential to work with a credible, trusted distributor to reach the physicians and medical facilities. Taking a look at Active Life Technology team, again, my name is Davis Breimer, and to your right is Alex Proctor. We are both students here at UCSB, and we both absolutely desire to bring on an experienced management team. Our advisory board offers many resources into the medical industry with over 70 years of experience combined, and this includes the inventor, Dr. Paul Hansma, medical device consultant, Dr. James Ryby, and marketing expert, Doug Sweet. Because of the uniqueness of Dr. Hansma's invention, this device will actually be generating revenue before and even during the FDA approval process as it's being sold to the research market. FDA approval for the fracture repair market is estimated to take 3 years and $5 million. We expect break even in year 3 with increasing revenues from then on. Again, we will first be focusing on one niche market in order to gain technology adoption and market credibility. Once this has been obtained, subsequent markets will be entered as opportunities unfold. These opportunities are represented by year X on the table you see on the screen. Prior technology funding and developments include 3 years of UC research in the Hansma lab with 100% grant funding by organizations such as NASA and NSF. As you can see on this slide. To conclude, I'd like to sum up by reminding you that bone health is a nationally identified problem, and there is a need. The osteoprobe is a pioneering product with 3 revolutionary markets. Disposable tips create a recurring revenue, and the osteoprobe is a unique and patented device. There's a long list of dedicated mentors, collaborators, and advisors who have spent their time and knowledge helping with this project and have agreed to do so in the future. At this time, I'd like to thank you for your attention, and if anybody from the audience has questions, I ask that you please hold off until afterwards. We will also be displaying our most recent prototype after the last presentation. At this point in time, I'd like to answer any questions the judges may have.
As far as the financial motivation for the physician to bring on this equipment, I believe you mentioned that this could replace existing techniques. What would be the financial motivation to take out what appears to be a large revenue generator for the physicians and placing your equipment in its place.
Right. I actually had a chance to meet with some people from Cottage Hospital, and their response to my question asking them that was that current techniques they use to analyze bones are not necessarily driving profits, mainly the fact that it's a large upfront cost and there is no disposable unit to it. So our device will be, because it's on the cheaper side or the less expensive side of the devices, more easily to obtain for a facility, and also has the disposable component to it.
You identified 3 different markets, and your point was that you go after the research market first. And my assumption there is because it doesn't require the FDA approval that you're going to need to get through on that. But what's the value proposition to the research market? Why would they buy it?
The best way to think about it is that in bone, like I was explaining, there are 3 different things you want to look at. Currently, to date, there has been no tool whatsoever that has allowed researchers to look at the 3rd parameter of bones. So it's currently an unknown that researchers have, from what I've been told, just been waiting for some sort of device to be able to look at it.
Do researchers buy those other 2 tools?
Yes. Or they share them with other areas of research.
How much research or product development is still needed to target your first vertical, the research stuff? No. How much development do you still need to do?
Before reaching the research
Before
market?
you actually have something that's productized.
Right. Probably, and that's a good question, probably around 6 months to a year, I imagine. The device is currently traveling around the world right now with the inventor. I think he's in Barcelona, and displaying it to leading researchers to gain their interest in it. And currently there are researchers who are waiting to get their hands on the device to start doing that process. So as soon as the company is ready to release the product, it will start at that point.
Yeah, I was wondering if you're familiar with Raman spectroscopy and whether you could compare it to that technology.
I'm not familiar with that, and I could ask my tech expert.
The measurements that are taken from the osteoprobe are physical measurements, whereas a spectra analysis is intrinsically non-physical. The data that's taken from the instrument gives us in vivo, on the surface of the bone, physical results that correspond to statistics that you cannot calculate using a spectral analyzer.
Thank you.
One more question. Sure. It seemed like you guys tried to go for cost-based pricing instead of value-based pricing. Why not go the value-based? It seems like you could charge 3 times, 4 times as much for your device, and it still you would still sell it. So that seems like the better approach.
Absolutely, that's a great point, and we will be conducting a conjoint analysis for market study for maximizing the price before we actually do go into the market and sell it. Just starting, we decided to go with the comparable price by asking physicians, what will you pay for this? Their first answer is, well, we pay this for what we have right now, but we will look further into it. Very good point. All right. Thank you very much.